Okay, welcome in everybody. Today is our Design 350 lab. It's Monday, October 25th, and it's 11 o'clock, and we are on our Google Meet right now. So let's go over, excuse me, real briefly, what's up for this week, and then I'll briefly go over the how to read the reticle on the theodolite to get your Stadia readings. That's really what I want to get across for the lab today, and then you can get ready to go practice. So this week is week 10. We're starting project work now. You've done your survey work and a lot of your background research on zoning and rental agreements and foster youth and SACOG and all that kind of stuff. And now it's time to put it to work so that it kind of gets driven in and makes some sense. So we're going to do our project number 1, which is centered in Hamul, which is San Diego County. And it's a client who wishes to build some tiny houses specifically in support of foster youth. That's the goal. So you may use Revit. I have Revit files, or if you're more familiar and want to do this in AutoCAD, you can. I do believe that this portion is easier in Revit, and it's pre-set up in many ways for you. But it's up to you how you'd like to do it. So we have our our lectures today, and we've got labs. Today is online, Wednesday is online or on campus, Friday is online only. So the only time we'll actually be taking readings will be on Wednesday. And that will probably be our last on-campus lab that's required. We do have a playlist. I don't know what's in there right now. I'm not sure anything's in there. These recordings will go in there. There is a reading list, which is your project work for project 1, and we'll go over that tomorrow. You can get with me on the appointment calendar, and of course we've got some samples for you. So there's weekly project resources. There's the requirements. There's your base file in Revit. There's your base file in AutoCAD. Here's sort of it's mostly what the project will look like. And here's, if you're in AutoCAD, a resource file that has your layers and your dim styles and all that other kind of cool stuff. And then another thing that we'll go over tomorrow during our lecture is sort of some notes on what your file should do. So you can see there's a lot of files here and a lot of things to do. In Revit, many of them just pop out and do their thing. But if you'd like to do it in AutoCAD, you're able to. So those are some resource files for you. There's technically no discussion this week, no simulation. The skill development are your theodolite readings, and that is what we're going to go over today. We'll take some last amphitheater stuff on Wednesday to fill in what holes we find when I post stuff tomorrow. Tomorrow I'll be posting your actual amphitheater theodolite readings, and of course you've got a project progress submittal. So there's 14 sheets with 30 views, and you have 2 weeks to do those. So your progress submittal should be about half of that. Okay? and then you'll have a collaboration to do. And I'll go over these in detail tomorrow. Um, yeah, oh, so close. You'll never get it right first time. And it's very hard to check your own work. So you'll be asked to post your work for your colleagues to go over. Okay? So that's what's up. Now, what I'd like to do today is go over these Stadia Marks and see how you read them. In the past, you've seen that we've taken a tape measure and we've done the readings using a tape measure for the distance. And that has some positives and it has some negatives. Really, many surveyors use one, two, or three different methods all at the same time because there's nothing worse than getting a distance measurement done. Welcome in, Leah. Nothing worse than getting a distance reading and seeing that there might be some sort of a problem and having to go slog back out there to get them. And so if you can take the same distance reading two or three different ways and get a very, very similar number, you feel really good about that reading. So we're going to use another type of reading today using the reticle on the theodolite using what's called Stadia Marks. And I've given you a little sample thing, just like last week I gave you a ton of theodolite readings where you could take the azimuth and the elevation and figure out if it was level and read the distances and just get all those drawings, all those readings done. And now I'm going to focus on the last thing, which is called the Stadia Reading, which is the distance between these two reticle marks. These two reticle marks. Okay? The vertical ones. And those are set up so that you can tell a distance. If you read the distance between these two marks and multiply by 100, then you're gonna have the distance. Okay, so let's say on this one, I read this, there's 0.1, 0.2, 0.3, 0.4, 5, 0.6, 0.7, 0.8, pretty close to 0.9. Pretty close to 0.9 feet. So I'd take 0.9 times 100. I would actually be 90 feet away from my elevation marker, my rod. Okay, so the theodolite to the rod is 90 feet. So I could come up here and type 90 feet. This is how I got it. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. So that distance between these two reticle marks is 0.9 feet on my rod. 0.9 feet times 100. That's called the Stadia ratio. And every piece of equipment has a different ratio. So you have to read what it is. I took this out of the user manual. 0.9 times 100 is 90. So I'm 90 feet away. Now it's not always that easy. I kind of adjusted this to give me really easy measurement readings. Okay, so sometimes it's maybe a little easier because they're not right on a number and you have to figure it out. There. And so that's what we're going to have going. Just a moment. Surfing today? No, but we can't. So, yeah, you can log in because we'll go over. Well, no, don't bother to log in. Um, that's really it for the lab. How are we looking on that? Does that make sense, Leah?
Yes, it does.
Okay.
Yeah,
And
that makes sense. It's actually really neat that you're able to do it without even like measuring or anything
yeah,
and being able to.
yep. Now I would always still measure just to make sure that I've got things going right. But then, if I got my tape out there and it said, 90.25 or something like that, I'd go by this one. Okay. And particularly, you're going to find this is useful when we do angled measurements. So when we're off at the angle, because it's really hard to run that tape at an angle. And of course, you found that it's hard to go through bushes and over rocks and around trees uh,
It
it,
is
it can be
just a little bit.
yeah, it can be really hard. So this is a good way to do it. So this week, it's just go ahead and get these done, save your file, and submit this file. We don't have a template this week, in a way, and I'll go over that tomorrow. So
So we just have the Stadia readings, the Theodolite Stadia readings.
the Stadia readings, and you've got this great big Revit file with
Oh,
14 sheets and 30 views, of which you need to do half. You're
okay.
going to do,
I was gonna say only 14 sheets.
yeah. Well, many of the sheets just pop out.
Okay.
Many of them are very fast because they just happen, right? You've been practicing. You can put grade on there. You can put stormwater plans. Many of them will be 15, 20 minutes.
Okay.
And it is a 2 week project. But there are
Nice.
some things that are going to take a while, and I'll be talking to our Design Hub team to provide some information to the rest of the people. So I know you're on the Design Hub team, and so we'll be talking with you about getting some data. Okay.
Sounds good.
So there we go. That's it for the lab recording for today. I'm going to go ahead and turn it off.